This conference will now be recorded.
Hello, everybody. Jordan Girth here from the National Weather Service Office of Observations. Thank you so much for joining us for our Satellite Book Club Seminar Series. This is session number 84. I hope you're staying well. Today's presentation, Augmenting Multispectral Satellite Imagery with Derived Product Readouts. The presenter is Bill Line, a physical scientist at NESDIS STAR. The facilitator for today is meteorologist and satellite focal point at the Weather Service Forecast Office in Grand Forks, North Dakota, Carl Jones. Just like to make a few reminders before we get started that the session is being recorded. There will be an opportunity for Q&A after the presentation. We're encouraging attendees, particularly from our field offices, to post your questions in the chat and field them there. We are also encouraging all attendees to sign in with their full names or specify your full name when asking a question in the chat. This will help us follow up with you after the meeting. We're always looking for future presenters, so if you have an application you'd like to share with your fellow forecasters in the field, please get in touch with us. The training team can help create training materials that may be unavailable or you may be unaware of. Brian Mott, the Office of the Chief Learning Officer, can help with that. Just like to give a brief update, we're very excited for the upcoming launch of GOES-T, which is set to lift off on an Atlas V rocket from Cape Canaveral Air Force Station in Florida in 19 days, 5 hours and 33 minutes. The 2-hour launch window opens at 4:38 p.m. EST. Stay tuned to NASA TV if you'd like to watch that live. As has been mentioned previously, GOES-T will be GOES West. I'd like to thank the TOWR-S team, particularly Kashad Bowman, the Office of the Chief Learning Officer, and the GOES-R and the GPSS program for their support of the Satellite Book Club. Also appreciate all of you for being with us today. Without further ado, I'd like to introduce Bill Line, who's no stranger to the Satellite Book Club, physical scientist with the NESDIS STAR Regional and Mesoscale Meteorology branch in Fort Collins, Colorado. In this role, Bill conducts research into the detection of various mesoscale phenomena utilizing NOAA satellite data. Bill, welcome back to the book club.
Thank you for the introduction, Jordan, and thank you everyone for joining us this morning, 1 hour earlier than usual. We appreciate it. So this idea of melding satellite imagery with derived products is something that I think some in the field are already doing, but something that we felt we really wanted to formalize and make available or make easily accessible to everyone within AWIPS. So Tim Schmidt really initiated the push to do something more formally, again, that combines imagery with derived products. So then Tim and I worked together to get it working in AWIPS, and then we took it to the Weather Service, got some feedback, and then took it to TOWR-S, and they helped us implement it. So it was a great lesson in really getting something through to operation. So if we go to the starting off with the next slide, why did we decide to do this in the first place? Well, we really wanted to broaden the use of those quantitative derived products that are available in AWIPS. We have a pretty good sense that they are underutilized. So your derived products being your cloud products, your TPW, CAPE, and your aerosol products, etc. Underutilized. And also we wanted to do this to help strengthen our user understanding of the multispectral imagery products, such as RGBs, your difference channels, those types of products. So by combining these two, we felt that we could accomplish these tasks. So if you're looking at AWIPS, if you're trying to look at all this information, a multispectral and RGB, in addition to some of those cloud products, you're taking up a lot of screen real estate, you can see in the left. So the method that we're implementing condenses that information down into what you see on the right, and that's what we'll be talking about. So moving along to slide 3, I do want to first note that this implementation is now available with TOWR-S RPM version 2, which was made available a few days ago, version 22, my bad. So what we did was we thought of kind of the most utilized multispectral products, mostly RGBs, but you can see in the left column other products too, such as split window difference, a sandwich composite, and geocolor. And we thought when we brainstormed the level 2 products or your derived products that went along with those RGBs and could really, add to those RGBs. And you could see those level 2 products in the middle column. The beauty of this implementation is that this is all information that is already available in AWIPS, so we're not adding anything, we're just bringing together information in intelligent ways. So moving on to the next slide, once we came up with these pairs, we ran them by some Weather Service colleagues for additional ideas to make sure that it made sense to them. And then we developed a series of menu items. Of course, I know more menus, but these are, at least for now, located in the local menu items. So if you go into the satellite menu, select local menu items, you'll now see an option that reads GOES RGBs with derived product readouts, and then you'll see the sectors, and then you'll see the product readouts. So again, what these are the listed RGB or multispectral product along with related derived products. And they're categorized in that menu based on application. And we've heard a lot of feedback from users wanting to order things or organize information by application. That's what we kind of did here with your cloud RGB. So day, cloud, phase distinction, nighttime microphysics, etc. Your air mass type products, and then your land or aerosol type combinations, such as geocolor, dust RGB, or your fire temperature RGB. Another nice part about this implementation is that it doesn't impact your existing perspectives or procedures, but if you want to implement these into your regular procedures, you could, of course, load them and then save them into your perspectives or procedures. And maybe in the future, these items will graduate to the more traditional satellite menu. And again, this menu system was also vetted by some of our Weather Service collaborators to make sure that it made sense to them. So going on to the next slide, the display. So once you select one of the products, what loads is what you're used to loading. If you would select the fire temperature RGB menu item, it would load the fire temperature RGB. So you're seeing what you normally see. The difference comes when you sample the scene. So when you turn on sampling and you see this wildfire hotspot or what you think is a hotspot, you sample it. Not only do you get that readout of the RGB, the red, green, blue components, but you're also now getting related information from the quantitative level 2 products. So in the case of the fire temperature RGB, you get the fire mask, fire area, fire power, and fire temperature derived products, so that you're getting more information than just the RGB when you're sampling the product. So you're not loading it, those derived products are not displaying. Where you're getting that information, again, is when you're sampling. And just as I run through examples, note that the color of the readout, so process fire cyan, matches the color in the product legend. We know that's fire mask. What does that 768K refer to? Well, we look in the product legend, red is fire temperature. So you get used to kind of looking back and forth between them to know what that readout actually refers to. Of course, a big concern I know to the users is performance issues. How does AWIPS handle this? Is it a bigger load on memory? Is it going to slow down my AWIPS? And what I found in testing is that, and others, it really didn't increase a memory load or performance worse than loading the RGB typically would. So maybe it's that the product isn't actually displaying. I think these derived products aren't a heavy load to begin with, but you're not actually displaying them. You're only sampling the readout. So going on to slide 6, we're going to now go through several examples just of why you might use these procedures. Again, you'd go into that local menu, you'd select air mass RGB plus moisture products, I think it says, and then this is what would pop up. So you see your regular air mass RGB as typically you would. You see thunderstorms developing across the southeast, but maybe you're curious about, what are those greens ahead of the thunderstorms? What is that environment characterized by, or behind this system across the Midwest? What do those colors mean? Is it moist back there? Is it dry? So if we go on to the next slide and sample the area, we see that, well, ahead of those thunderstorms, we're getting, what is that cyan? What is 1.4 inches? That's the TPW derived product. So we see that it's very moist. There's a little bit of instability. And so we're getting that, we're marrying that derived product information with the qualitative imagery. Looking behind the system, you see that it's bone dry, 0.1 inches of TPW, and of course, very stable. Moving on to a cloud example, thunderstorm example, looking at if you go into that menu and select the day cloud phase distinction RGB plus cloud products option, this is what would load. Again, same as what would load if you just load it from the RGB menu, except you also have these cloud products, again, that we chose because they made sense to go along with this RGB. So if we go ahead and sample areas across the scene, we see in the upper left, you're sampling this clear sky area ahead of the storms, and you see, oh, okay, it is clear, there's no clouds there. Looking in the upper right, maybe you forget what this cyan color means, or you're curious about those small clouds there. You see that the cyan in the legend, okay, that's cloud top phase, that's a water cloud. That's what cyan means. Okay, I remember that. That makes sense. These are very shallow, small or short clouds. That cloud top height only between 4,000 and 5,000 feet, and maybe optically relatively thin, 9.5 value there. If we sample the thunderstorms, okay, I know those are thunderstorms. Obviously, in the lower right there, that those are ice in the top from the cloud top phase product. Very tall, okay, 43,000 feet. This is information that we wouldn't otherwise have from looking at the RGB alone, and optically thick. And then to the lower left, maybe you forget what this greenish color is when you're getting a transition from the cyan to the more yellow. So you sample it in over a mixed phase. So maybe we're starting to glaciate, maybe convection's starting to grow here. It's about 20,000 feet, so about half the size of those mature thunderstorms. So again, melding that quantitative information with the qualitative RGB. So going on to another cloud thunderstorm example, this is the sandwich composite, and this is kind of the old school sandwich composite versus the RGB. Looking at thunderstorm activity across the southeast. Maybe you're working in Mobile, you're monitoring the 1 minute sandwich product. Again, this would load from those menus, and then you want to sample some of that deep convection, those red areas, the bubbling thunderstorms in the northwest part of your forecast area. So you go ahead and sample that area, Kashad, and you know more useful information. Not only are you getting the IR brightness temperatures, but you're also getting the cloud top height. Wow, over 50,000 feet. These are obviously ice clouds, but you're also getting the information from the rain rate derived product, over 1 inch per hour rain rate. And I believe this rain rate algorithm is going to be updated soon. So maybe someone could drop a note in the chat about that. And of course, that updated algorithm would become a part of this as well. So on to the next example. Of course, this isn't just for the Eastern US, it's works for goes west as well. We have derived products out west now, more recently. Maybe you're in the Pocatello forecast area monitoring clouds, and in this case, monitoring low cloud evolution, but you're not really sure, what these colors mean. It's the winter, so they look a little different than they do in the summer, but you're curious about the potential for a fog or visibility restrictions in your area. So you go ahead and sample the evolution of clouds as they approach the Pocatello area. Maybe you're working on your TAF there, and what you'll get with nighttime microphysics RGB is fog probability readout from the fog and low stratus products, which are now available in AWIPS. So again, matching the colors in the readout with the product legend, you see that you have about a 3 out of 4 chance that those clouds are resulting in NVFR conditions, and almost a 50-50 chance of IFR, and even a 1 out of 4 chance of LIFR. So again, it's adding quantitative information to those colors in the RGB. On to the next example, still hanging out west over the far southwest California and southwest Arizona. Maybe it's a windy day and you're monitoring for blowing dust. So you load the dust RGB plus aerosol product combo, and again, it'll load the dust RGB. But you see, these plumes of pinkish colors streaming south. So you want to know a little more about what that is. Is it clouds or is it dust? So you sample one of those plumes and you get the dust detection product as well as aerosol optical depth, and you see that this is the algorithms telling you that it's a high confidence in dust. So you're combining the qualitative, what you know about the RGB, maybe you're already confident that that's dust, but this product might, further your confidence that this is indeed blowing dust here in southwest Arizona. On to the next example. Of course, fires in the west. Forecasters are going to be monitoring for maybe new hotspots. And in this case, looking at the fire temperature RGB our combination. As I mentioned earlier, you also get those level 2 fire products. And there looks like there's a faint hotspot developing, but maybe you're not 100% confident. There's some clouds in the area, or maybe you just want to know more about that hotspot. So you go ahead and sample it, and you see that you get all that information about the fire area power and fire temperature, and the algorithm is confident that it is indeed a fire. So next example, we move outside of the CONUS. These are available, where the level 2 products are available, OCONUS wise. So over Hawaii, Alaska, and Puerto Rico, we have these same procedures in the menus. But again, in some cases, the level 2 products might not reach, especially in Alaska. This is the new GeoColor implementation, and maybe Lee can drop a note on when this is going to be available in all offices. But GeoColor is a versatile product. It has, I think, many applications, so it's a little tough deciding what we wanted to put with it. But we added one of the fire products, fire temperature, and that actually won't be transparent. So if there was a hotspot in this case, the fire product that would show up on the screen, but the other ones remain transparent. So maybe you're curious about the surface skin temperature while looking at GeoColor, or aerosols, or even fog at night. So in this case, downstream of the Big Island, you see kind of a haziness amongst the clouds compared to other areas. So we know that this is an active volcano and you have some emissions downstream, so maybe you want to sample and compare that hazy area with other areas. So you go ahead and sample that location, and you see that, yeah, indeed, the aerosol optical depth is actually elevated 0.29 compared to what other areas were, which tip of less than 0.1, so negligible, not as much there. But aerosol optical depth here showing, there's a signal that it's detecting downstream of the volcano. And then at night, similarly, you could sample maybe what do those blue things mean again? It's clouds. You're probably aware of that, but they're water clouds, but you want to get your restriction probability, and in this case, NVFR around 50-50. So last example now, over Alaska, again, not all the products reach into Alaska, but some do. So looking at the day cloud phase distinction iteration over Alaska, these, especially around low light scenes, even over the CONUS, but over Alaska too, the colors change a little bit with your reflectance bands, and maybe your confidence deteriorates a little bit around sunset or up north, where again less sunlight, so less reflectance. So you go ahead and sample some of those clouds east of Anchorage, and you see that you have ice clouds and not very tall, but maybe generating some weak rain or snow showers depending on the temperature there. So now moving on, those are all the examples. Of course, there's some other products I didn't show. The split window difference combo is a great one for also dust detection, but also remember split window difference for low level moisture gradients and boundaries. So we have some moisture products with that one, and definitely recommend you check them all out and mess around and see what you like. So I mentioned we got feedback from Weather Service. In general, they thought this effort was worthwhile. Some were actually already doing it, but it was nice to formalize this. They agreed that it would help to increase the use of otherwise underutilized level 2 products, which do have some value, but they also liked that this was an efficient and pretty creative method of doing so. Obviously, the main concern from our feedback and from us is not wanting to create new AWIPS performance issues. And as I mentioned, we didn't really notice any. So going on into some of the more detailed feedback, I just wanted to highlight some from Alaska region. They really liked the idea and mentioned that they would redo some of their perspectives or procedures to include this. From Eastern region, very good about noting various concerns, so that helped us to look for some of these problems that might arise. And then from Western region, liked really anything that could simplify the menus. Obviously, there's a lot of menus, and this is a menu that brings many items together into one menu. Moving on to just a little bit more additional feedback. Oftentimes a forecaster does want to use the level 2 products, but they're really not sure which ones to load. So these kind of, do it for you. They show you which ones should be loaded in certain situations. And then from Southern region, again, mentioning that they don't really notice many forecasters using the Derived products. So this is a way to increase their use. And again, noting not wanting to create performance issues. So moving on to the last slide, that is the end of my presentation. Thank you all for listening. Again, these menus are now available if you install TOWR-S RPM version 22 from the satellite local menu items. You'll find these. And I just want to close with saying that obviously we can create additional options. So if you have other ideas, please pass those on to Tim and I or the TOWR-S group. Thanks a lot, and I look forward to answering your questions.
All right, thank you, Bill, for that presentation. We would like to, for you to stay on for further discussion, and we would encourage participation from the field offices as well as regional headquarters. And if you would post a question or interact within the discussion, we would ask that you would please specify your full names in the chat. And we'll also be sharing a feedback form if you would like to provide any feedback in a short survey on these Satellite Book Club presentations. And as a reminder, in a week from today, Thursday, February 17th at noon Eastern, Javier Villegas Bravo, a GOES-R satellite liaison, will discuss OPC prob severe lightning cast testbed activities. And if you would like to contact the TOWR-S team, that's Lee Byerly and Kashad Bowman, for questions about the Satellite Book Club or for configuration of satellite products, we should be dropping that contact information in. And I'd like to finally remind attendees to submit questions or indicate if they would like to ask a question verbally within the chat. And I will go ahead and read off a couple of notes that was dropped into the chat. Lee Byerly referring to an update on the rain rate product. It is in progress for later this year with plans to pull in microwave data as part of the update. And he also dropped in another note on geocolor availability for all offices is estimated for mid-April. They're currently in the evaluation phase with a few dozen sites. Gene Bruschi had asked, referencing this geocolor, how is a new geocolor representation different than the current version? And Lee had responded to that and said the representation is the same. The resolution is increased, though to 500 meters for the CONUS and Mesoscale sectors, as well as Alaska and Puerto Rico sectors. The current geocolor is, excuse me, primarily provided at 1 kilometer over the regional LDM, and the new version is readied at the site, which will reduce LDM transfer bandwidth. All right, so thank you for providing those notes, Lee, and asking those questions, Gene. We have a couple more questions, and again, feel free to type in the chat your questions. But as we go on, I'd like to ask if there are any cryosphere products in these readouts. That'd be a question for Bill.
Yeah, that's a good question. Not currently. The cryosphere products, snow, ice products are not yet available in AWIPS, but when they are, I think we have plans to create some more of these combinations that make sense, perhaps marrying the day snow fog RGB with some of those products. And maybe someone else could put a comment in chat or mention when those are expected to arrive in AWIPS, those snow and ice products. Good question.
All right, thank you, Bill. I have another question, since we're not seeing any in the chat just yet. Can non-satellite gridded products be included in these displays?
Yeah, that's something that we received some feedback on and have also been thinking of, maybe products that maybe have data gaps, like sea surface temperature. It's pretty good from the NWP, and maybe you want to combine that in with some of these products, or other NWP type fields that might make sense to go along with the satellite. We could definitely do that. I'm not sure if the gridded data might increase or might be bad for band or memory load, but that's something I think we're going to test and see if we can develop products that bring in the gridded data with the satellite data that makes sense.
Yeah, referencing the NWP type data that would complement this types of displays. As you were going over your presentation, it kind of occurred to me that maybe we could, I don't know if it's feasible to have two types of readouts at the same time, but you were talking about the convective scenario when you're trying to assess cloud top height during different phases of cloud growth and convection growth. If you still have the capability of having the sounding readouts, and if those cloud top heights would be, maybe kind of reaffirm your parcel tracing whenever you're trying to find out if maybe these parcels are utilizing all available instability. And obviously there's other types of factors that you have to take it with a grain of salt from NWP readouts like that. But it would just seem interesting how you could use that type of cloud top information, those hard values, with maybe your sounding analysis, particularly like a meso analysis type environment. Yeah,
Carl, that's another great idea. I like that, and that's why we wanted to do this, and we welcome ideas from the field so that we can test them out and see how well they work.
Good. It looks like Lee had dropped in another comment. I'll go ahead and read off some additional comments in the chat. The GOES-R program is working on new algorithms, implementations of ice concentration and extent. It is on a development server now, flowing into the GeoCloud. Please reach out to Lee if you would like to see these products. And a couple more comments from Jamie Daniels is that according to the latest GOES-R development schedule, the updated GOES-R rain rate product is planned to be implemented into operations May 19th of this year. And last comment from Lee at the moment. I apologize if I do not pronounce the name correctly, but Yinghui Liu from NESDIS Sims will present on GOES ICE products at the satellite book club in late March. Thank you for those notes and comments. I actually have an additional question to ask for you, Bill. So with level 2 products, it may seem like there might be kind of perhaps a steep learning curve to level 2 products just because of general unfamiliarity of maybe specific thresholds or just how in general to interpret these types of products, or just to interpret these types of products. And without intimate knowledge of these readout values and the operational significance, how can we help forecasters confidently understand and utilize these level 2 products, and for that matter, RGBs?
Yeah, that's a great question, Carl. And one of the most significant reasons we did this was that this would help user understanding of some of these level 2 products by, not only are the level 2 products maybe helping you understand the RGB interpretation better, but having an RGB that you're familiar with and you understand the colors, and assigning those colors to the various level 2 information, I think will help folks better understand the level 2 products and what they're telling you as well. But also, obviously, these level 2 products, derived products, weren't put into AWIPS without training. There's training available. The quick guides obviously are available. There's a quick guide for each level 2 derived product, and I'm pretty confident there's other training as well available for those products. So certainly, if you want to know more about these products, you can go out and find that.
All right, thank you for that. And I went ahead and dropped in a link to one of the quick guides that has a pretty lengthy list of both level 2 products and RGBs, as well as other things within the chat. So we'll have maybe a last call for questions or comments if you'd like to ask or any and that sort of thing. And I guess I'm curious, Bill, to hear your expectations for people trying to utilize this, and how maybe how can we really get the advertising campaign going for really trying to start using these types of these displays and ultimately all the products available to us that might not be so obvious.
Yeah, I really hope that folks on this call, maybe you got or if you're not on this call, you got the RPM update and you saw that this was an update, so you see it. And I hope that people are curious at the very least and check them out. And if it's not your thing, you don't find it useful, maybe reach out and see how it could be useful to you. And if it doesn't work for you, that's fine. You don't have to use it. But I think there's value here if you're curious about extracting as much information from the satellite products as you can. I think at least give it a shot. I'm sure we'll probably put out some blog posts, and hopefully people watch this presentation after the fact to go back, check it out, see what's available, and hopefully get in there at the very least on a quiet day and check it out and see what you think. And really, if you have any feedback or ideas, we do definitely want you to reach out. So I look forward to hearing from folks on what could make this better. Maybe it's how they appear in the menu, or maybe it's other combinations. We definitely want to get that feedback on what's going to be most useful to you, the users.
Yeah, I really think with the continuation at least of the number of spectral bands that we have right now, and and how they're used downstream to make products as well as making RGBs. Looking ahead into the next generation of satellites, a platform like that. These types of multispectral imaging, as well as associated level 2 products, are not going to go anywhere. If anything, if we get any more spectral resolution in the next generation satellites, we might even see more or additional type RGB and L2 type product readouts. So I definitely think it's worthwhile, becoming comfortable with your RGBs and your other level 2 type products, because we're only getting more. Looks like we have Chris Whitehead put in a question. He said, this one's for Bill, and he says, I think this type of display can be very useful. Can we provide feedback directly to you and also about any local configuration changes we may make?
Yeah, I think that's fine. If you send it to me or someone with TOWR-S or Tim, yeah, send it to me and we'll all be talking to each other and in order to test these out. Yeah, I think that's fine. Yeah, any changes you make that you find that work, I think it's valuable for us to hear, so that we can test it, maybe pass it by some other folks and see if it's appropriate.
All right, thank you, Bill. And again, as you can see on the screen in front of you, it's Bill's email address. If you want to reach out to him, you can find him at that email address. It looks like we got an additional comment that came in. It said, thank you, Bill. It will be a great opportunity for users to promote more use of L2 Cloud products. I will reach out to you and ask how to add new products. That was from YJ No. Thank you. And if anyone doesn't have any further questions, I think we will go ahead and adjourn this Satellite Book Club meeting. And yeah, Jordan, I will throw it back to you.
Okay, thank you so much, Carl. Great discussion there at the end. And of course, thanks to Bill Line, our presenter for today. It's a very interesting topic, and I think we are still learning about how to best apply the L2 products and how to use them in concert with the RGBs, which are certainly popular at our field offices. A very interesting topic. I would like to make sure, if you are from the Weather Service offices, you are aware that there is a new version of the TOWR-S RPM, and that includes the GOES RGBs plus the L2 readout combos that Bill was talking about today. There's also additional products that may be available over the regional LDM that you can have access to through this TOWR-S RPM. So please talk to your SU or ITO if you're interested in updating. We highly encourage you. We have a great TOWR-S team that tailors this particular package to meet the needs of the field. So we highly encourage you to upgrade. And of course, let us know how we can help you. And I believe you'll see a slide there coming up shortly with the contact information for our TOWR-S team. You can always contact Lee Byerly or Kashad Bowman for anything related to the configuration of satellite products or questions about the Satellite Book Club. So with that, I will wrap it up for today. Thank you to everyone for joining us. I hope you will join us again next week. We will be back to our normal time at 12 noon Eastern. And until then, please stay well and see you then.